Hi, I'm Terry Klinker. Our next subject in decision analysis is going to be indifference points. Now, in the last section, and you should still have the notes for this available to you, we did a break-even point. So what's the difference between indifference point and break-even point? Break-even point, we had our two options. We had option A, vendor A, and vendor B. And we found out what the profit was. The profit was 8 times the quantity minus the $50,000 fixed cost. That was going to be our profit margin for A. 10 times the quantity minus the $70,000 fixed cost was our profit margin for B. And the break-even point was the special case where profit equals 0. And the break-even point was the quantity we needed to produce to make no profit. So what's the difference between a break-even point and an indifference point? An indifference point is where you are, just by definition, indifferent. You don't care. Well, where don't you care? You don't care if you get the same amount of satisfaction from two different options. So in this case, it would be where the profit that we get for option A equals the profit that we get for option B. If the profit margin is the same, then we are indifferent as to which option we select. Remember, we're trying to use analytics to help us make a decision. All right? So the indifference point will be where if we're indifferent between option A and B, so that's where the profit of each of them equals each other. Well, let's take a look at how this works. The profit for A equals 8x minus 50,000. So we can just substitute this profit. We can put that equation in there. 8x minus 50,000. Profit for B is 10x minus 70,000. Now in this case, we can just sit there and now solve for x. We'll know what the indifference point is. The indifference point, again, being where we make the same amount of money from each one. Do a little bit of algebra here. Take the 8x to the other side. I end up with 10x minus 8x is 2x. Minus 50,000 plus 70,000 is a plus 20,000. So we end up with a break-even, an indifference point at x equals 10,000 units. So if our expected sales are 10,000 units, we are indifferent as to whether we use vendor A or vendor B. We really can't make a decision here. If the expected volume is 10,000 units, it doesn't matter, so there is no clear-cut decision. Now, once you've come up with your quantity, there are ways to check it. The easiest way is just to turn around and put them back in the equation. If I put 10,000 into each one of these equations, all right, so profit for A is going to be 8 times 10,000 units, $8 profit for each of my 10,000 units, minus the $50,000 fixed cost that I have to absorb. This gives me 80,000 minus the 50,000 fixed cost, and I end up with a profit of $30,000. If, on the other hand, I calculate it for option B, profit for B is going to be 10 times that $10,000 units, minus the $70,000 in fixed costs, gives me $100,000 minus my $70,000, which leaves me with $30,000 of profit. The two equal each other, so again, I am indifferent. What can I do with this? What does this mean? How can I apply this to a business situation? Well, the bottom line is, at 10,000 units, I'm indifferent. What if it's 8,000? What if it's 12,000? What decision would you make then? What we do is, once we've found the indifference point, then we turn around and we build what's called an indifference table. Now, in our indifference table, we have several columns. The first one we have is the indifference point itself. Now, in this case, we only have two options, so we only have one indifference point between the two options, 10,000 units. Under this one, put in your indifference points. In this case, it's 10,000. Now, once again, I can't really make a clear decision here. So just kind of draw a line across here. We're not going to worry about what it is at 10,000 units. We know that we're happy with either decision at 10,000 units. We want to find out if it's not 10,000 units, which option would we prefer to go with? So the next column you have is called a test point. A test point will be any point that is not an indifference point, any point that is between your indifference points. Now in this case, we have 10,000 as our indifference point. On the low side, what would you go with? Well, we could go anywhere down to 0. It's between 0 and 10,000. You cannot have a negative quantity. For most of this class, for most decision analysis classes, the amount that you have, your quantities, must be greater than or equal to 0. Can you buy a negative quantity of something? Can you produce a negative quantity of something? No. Once you get to 0, you're done. So we're going to find out which is the best option between 0 and 10,000, and we need to pick a test point there. Now, what test point would you suggest? I always suggest picking the one that's easiest to calculate. In this case, 0 is an option. That would be the easiest to calculate, so I would take a test point of 0. On the other side of it, it's between 10,000 and infinity. Now, just so you know, never pick infinity. Very difficult to calculate. We just need something that's bigger than 10,000. I'm going to pick a test point of 15,000. 15,000 units. Once we have our test points, we need a column for each option. In this case, we have two options, so we want to find out what the profit for A is, what the profit for B is. We calculate the profit for A for each of our test points, the profit for B for each of our test points. We don't calculate it at the indifference point because we know it won't make a difference. It'll be the same. We want to find out which is the best option this way. So for profit for A, we plug 0 into our original equation, 8 times 0 minus 50,000. So profit here, 8 times 0 minus 50,000. If we had a quantity of 0, we would earn a minus 50,000 in profit. Put it in for B, 10 times 0 minus 70,000. That's going to give us minus 70,000 in profit. Do the same thing. I'm sorry, I put it in the wrong column. Let me erase that and do it again. This is for B. It'd be 10 times 0 minus 70,000. So the total profit is minus 70,000. You can't see this, but the cameraman's laughing hysterically at my error, all right? Now we calculate it for the other test point, 15,000. So we have $8 for each of my 15,000 units minus the 50,000 of fixed costs, and we would end up making, it'd be 120,000 minus 50,000 is $70,000 in profit. On the other side, we'd have 10 units, or $10 per unit times 15,000 units minus the 70,000 in fixed cost. So my profit at 15,000 units would be 150,000 minus 70,000, or 80,000 units. When you go through and do all this, we can now figure out between 0 and 10,000 which is our best option. We could lose 50,000 or 70,000. The better option here would be to choose A. The profit is higher. Yes, it's a negative profit. It's actually a loss. But we lose less money this way. At 15,000, we could make 70,000 or 80,000. We would choose that. So what does this mean? It means that if the quantity is between 0 and 10,000 units, 0 to 10,000, we would choose option A. It's the highest profit. If the profit is between 10,000 and infinity, we would choose option B. It is the highest profit. Now the question I get on this would be, okay, why did you go all the way to 0 and 15,000? What about what if it's really close to that? Is it still, can you tell the difference? And the answer is, yes, you can. Let's put it in there and find out. What if I used, instead of 0, I need a number less than 10,000. What if I used 9,999? Well, to do that, I just do 8 times 9,999 minus 50,000. You go through that calculation and you end up with $29,992 in profit. If I take 9,999 and plug it into this equation, 10 times 99.99 minus 70,000 leaves me with $29,990. Take a look at that. I make another $2 here more than this. So it's less than 10,000. A is still your best option. Do the same thing for B. What if I used, instead of 15,000, I used 10,001. Plug that number in there. 10,001, 8 times 10,001 minus 50,000 gives me $30,008 in profit. 10 times 10,001 minus 70,000 gives me $30,010. This is still greater than this, so my best option is still A. If you want to get even closer, if you went 99.9, you'd still make more money with A than B. It'd be just a couple pennies, but it would still be there. And 10,001, if you went to 10,000.1, you'd still make more money with option B than A, but again, you're just talking about a couple of pennies. This is for an easy decision with only 2 options. What would you do if you had more than 2 options? Well, we'll approach that in the next video.